So hi and welcome to the third day's training session on Google Earth Engine from beginners to advanced course. And I am course coordinator. Okay, so basically this is our full course content for the 7 days, and we will complete all of this course content one by one. And basically today is our third day, and third day's course content I will be trying to complete the first of all how to filtering and displaying the satellite images. Mainly in this time I will try to show you that how you can easily filtering the Sentinel-2 Satellite Imagery, and yesterday classes we also completed the Landsat. Okay, so now today I also try to show you that Sentinel-2, and after this I also try to show you that how you can easily monitoring the normalized difference water index using the satellite images. Okay, then how to add the legend. So mainly we can add the legend in Google Earth Engine two types. First type we can add here the gradient, and second type will be another legend called the chart legend or any specific properties legend we can also add here. And then LST monitoring. So mainly in this time I also try to show you that how you can easily monitor the land surface temperature. So mainly in this time here I use the MODIS satellite imagery, and after this I also try to show you that how you can easily make a time series chart for the LST. And then NDWI calculated from the MODIS and Landsat data, we also covered this part. Then visualization the DEM of hillshade and slope map in Google Earth Engine. So mainly in this time here I use the DEM data set for the NASA SRTM data set. So that I use this data set for making the hillshade and slope map. So let's start. So first of all, you can see this is the filtering and visualizing satellite images in Google Earth Engine, and we already know about that when you filter any satellite imagery such as Landsat or Sentinel, it depends on your many factors. Suppose you want to make the Landsat or Sentinel image for your specific region or your specific time frame or your specific image properties, we can filter our satellite images mainly three factors. First factor is that suppose you want to make the Landsat image for a specific boundary. Suppose I want to need these satellite images for my region of interest, Dhaka city. Okay, then I also need to these satellite images for a specific properties. I want to need only for those images which image will not be more than 1% cloud cover. This is the another properties. I want to need only for those images for the year of 2017 on 17 or other specific time frame. Okay, so this is the another factor. So we can also same factor apply when you filter our Sentinel-2 satellite imagery. Okay, suppose I want to need for the Sentinel-2 satellite imagery for the region of Dhaka city. I also need to I want to also need for this image will not be more than 1% cloud cover. I want to need for the specific year of 2017. I want to need these images. So when you filter these images, we also maintain this three factor. Okay, and in this time I also try to show you that Sentinel-2, suppose you want to need, and I also try to show you a project. That project you can easily use for the dry season and wet season. I suppose I want to also try to show you that part how you can easily use here the dry season. Suppose this is the image for the dry season, you can see, and I also try to show you that how you can easily do this for the dry season. And you can also see here there is the another part. You can see this is the wet season image. You can see this is the same place of the wet season, but in this place we can see here the sum of the cloud. And in this training session I also try to show you that how you can easily remove all of the cloud from the satellite images. You can see here the sum of the cloud in the wet season. Okay, so mainly wet season we can see it's our satellite images some cloud, and we can easily remove all of this cloud from the satellite images using the Google Earth Engine platform. Okay, and And I also finished this part when the next class I also try to show you that how you can easily remove the cloud and haze from your satellite images. And then we also move to the dry season NDWI. We can just take this dry season satellite images of the Sentinel-2. Then we will move to this calculated the dry season NDWI, and we can get this map like this. This is the dry season, and we also do for the similar thing for the wet season. So you can see this is the wet season, and we also calculated all of these things using the Google Earth Engine platform. So let's move to our code editor and try to show the practically how you can do this. So I simply open my code editor. So I just open this my code editor and try to show you this all of things one by one. So first of all, I simply in this time here I use the Sentinel-2 Satellite Imagery. So for this I simply import here my dataset of Sentinel-2 Satellite Imagery. So we can easily do it. I simply browse the data catalog, click to here, browse data catalog. Here you can get all of this dataset about our Earth Engine data catalog. We can get the Landsat mode is Sentinel. In this time here I use the Sentinel, so I simply click on the Sentinel, and then I simply use here this I use here the Sentinel imagery. So I simply click on the Sentinel, so it will be loading here. Okay, so here you can get all of the Sentinel-1, Sentinel-2 multispectral instrument. In this time I use here the Sentinel-2 multispectral instrument, and where we can part the top, you can see this is the surface reflectance and this is the top of atmospheric reflectance. In this time I simply use this dataset, so I simply click on here. Here we can get all of this dataset information about all of the part about this dataset. I can simply get all of the information from here. And now I want to try to show you that how you can easily use this dataset and filter your specific boundary and a specific time frame, how you can easily get this satellite images from this dataset. Okay, so first of all you need to import this dataset in your code editor. This is our code editor, and in this time I just simply copy this collection snippet, and we already know about that how you can easily filter this data, import our dataset. So I simply copied and paste here in my code editor. Here you can see this dataset will be imported, and after this I can simply use here a function, and I can give a variable name. First of all I want to take a variable name. Suppose in this time I simply use here this variable name is the Sentinel-2. Okay, I simply use here the Sentinel-2, and you can see this whole collection of the Sentinel-2, it will be stored under this variable. Okay, so now if you want to check how many images will be available for the whole world between this time frame year of 2015 to present time, how many satellite images will be available, we already know that about the function print function. I simply use here the print function, and after this I simply paste here the Sentinel-2. This is my variable name. I just paste here, and after this simply use here the size function, and then simply click to the run. You can get the how many satellite images will be available for the whole world between this time frame. Okay, so we can see there is the not found. So why? So Sentinel-2, this is the Sentinel-2, and I simply use the size function. I just pinned it, so click to the run. Image collection load asset, the command not found. Why? So I simply use here this variable name Sentinel. Okay, I simply use here the print, and then simply use here the Sentinel. This is my variable name. After this simply I use here the size function. Okay, then click to the run. Okay, so this it will be not computed in this time, so I think that there's some error or technical issue. Okay, first of all we will filter the satellite images. Suppose you can see this is the whole collection of the Sentinel-2 imagery, and now I want to filter this Sentinel imagery for my specific region. Suppose I want to show these satellite images for my region of Dhaka city. You can see this is my Dhaka city boundary shape file, Dhaka district boundary shape file. You can see I want to use this shape file in here. So you can see I just simply click on the import. This shape file will be imported. Okay, you can see this is a default variable name is the ROI, and I simply change this name. If you want, you can simply change it or not, it's totally depend on you. I simply change it and give this name is the ROI. Okay, so now I want to intersecting with this whole collection with my region of interest, this boundary shape file, and we already know about this function. This function I can simply use a variable. Suppose this variable name, I can give this variable name is the image. Okay, and after this I just use here the whole collection Sentinel-2. This is the whole collection. I simply and then I simply use here the filter bounce function. We already know about this function filter bounce. Okay, this filter bounce function, it's intersecting with my whole collection with my region of interest. In this time my region of interest is that ROI. I just put here the ROI. Okay, so now I want to check how
so it's the same process as last time.
Yeah, same process of the last time when we filtered the Landsat images. Just we can change only for the image properties, just it, because Landsat and Sentinel image property is not same. Okay, just we change it, then all of the will be same process. So now I want to check how many images will be available for my boundary. So I simply check it. I simply use here the image and I paste here. After this I simply use here the size function. Okay, then click to the run. So now it will be computing, but it not computing in here. Suppose what's the wrong, I don't understand this time. So image collection load, image collection asset is not showing in here. So okay, not done already. So I simply write this code. Suppose you can see I simply it will be filter bounds will be intersecting with my ROI. Then I also need to filter some specific properties. Okay, so when you filter our specific properties, we use here the filter metadata, and we already know about this function filter metadata. Okay, and this filter metadata, when you use this filter metadata, here we need to do the three argument. First argument is the name, second argument is the operator, and third argument is the value. So here I put all of this one by one, and then I simply use here this function. So in this time, what is our image properties name? So I can get the image properties from my in here. You can see this is our image properties. So image properties, and here I can get the different types of image properties: cloud pixel percentage, cloud coverage assessment. Okay, so in this time, suppose I want to use here the cloud pixel percentage, I simply copy this properties name and paste here, and just simply use here the single quote or double quote because it is the string. I simply paste here, and then I simply use here the operator. I think I use here the less than 1%. I want to check how many less than, and then I simply put here the value. Suppose I want to need only for those images which image will be not more than 1% cloud cover. I simply use here the 1. Okay, so then I also want to filter this image for my specific time frame or time boundary. I simply use here the filter date. Okay, I simply use here the filter date function, and after this I just put here the start and end date. And for this I simply use here this image collection. Suppose I just put here the start date will be that 2020 1st January 1st January. Okay, and end date will be that I simply put here the end date is that put here the 2021 1st January. Okay, I just put here the this thing, and then I also try to check it this. So how many images will be available here, but it not working in this time. I don't understand what's the problem in here. So simply click to the run. Okay, so you can see it will be not loaded. So okay, don't worry. So I will try to finish this code. So now you can see I can get filtered this image, and I want to calculate it from here the median or mean pixel value. So I simply use here the median. I want to take here the median. Okay, and then I also need to clip with my region of interest for ROI, and then I simply show this map add layer. I want to simply use here the map dot add layer function, and you can guess it what is our object name. Object image. Okay, so I simply copy this variable name and paste here. After this I remove all of these things. Okay, then click to the run. Okay, it's not working here. So I also try to check this image. So this is our image collection. So I simply copy this image collection in here, and then I just put here this. Okay, so this is a Sentinel.
Maybe something wrong with the data set.
Yeah, I think.
Because when you also wanted to put the image collection, it didn't show.
Yeah. So I simply search here the Sentinel-2. Okay. So this is our image collection. Okay. So in this time I just simply import this. Okay. You can see image collection. Then I simply change this variable name in here, Sentinel-2, and remove this line of this code. So then click to the run. I think it will be work now. Okay, so I think when you import this from here, it gets some error because I think there's something wrong about their technical issue or other. Actually Google Earth Engine will be all time they are updated something. Okay, so that's why it will take problem, but when I simply import from here, then it will be okay. Okay, so now I also focusing the shapefile. So when I focus the shapefile, first function I simply use at the map dot center object function. Okay, and then I simply focusing my ROI, and also zoom level will be 10. I simply put here to 10 and click to the run. So now I can get this result from here. You can see, but this result you can see it will be appeared, but this result is not good looking because you can see here I did not add any band combination or any visualization parameters, so that's why it will be look like this. So now I simply use here this the band combination, as well as I also use here the stress. So I simply use here this, you can see setting button, and simply click to here. Here you can get the band combination. Okay, so I simply use here the B4, V3 and V2 true color composite, and also increase the stress 98%. Okay, then simply click to the apply. You can see it will be added in our image collection. Okay, it will be appeared. Okay, so now you can see this visualization parameter will be not added in our code editor. Okay, just I simply click to import, it will be a new line of code will be added. You can see this is the image vis param. I simply copy this, and just after object name image I just paste here. After this I simply use here this is the true color. I gave the layer name true color. Okay, and then simply click to the run. You can see this image will be added in here. Okay, it will be appeared, you can see, and you can see how many images will be available between this time period. I want to check it, so I simply commenting this line, and then I simply use here the print function. Okay, simply use here the print function, then I simply call the image, and then I simply use here the size function. So now it will be showing the how many images will be available between this time period, year of 2020. So it will be appeared. You can see there is a total 55 images will be available between this time period, and this 55 images will be less than 1% cloud pixel percentage, and this 55 images will be straight in my region of interest Dhaka city. Okay, and I want to check when this image will be capture time. I want to check when this image will be taken, this satellite. So I simply print this image. You can see now we can get all of the information about these images in here. So here you can get all of the images information. You can see, simply click the feature. Here you can see this first image will be taken in this time, year of 2020, 17 January. Okay, we can get all of the images will be the first 1, 2, 3 image will be taken at the 17 January. Okay, then you can see this is the fourth image will be taken at the 22 January. Okay, so we can get all of this date about this, and you can see every specific image has a 17 bands. Okay, every specific image has a 17 bands. We also check here, you can see there is the B1, B2, B3, B4, all of these bands will be available. And if you want to know the band description, simply click to here. Here you can get all of this band description. What is the B1, B2, B3, B4, B5, B6. Okay, we can get all of this band description, name, resolution from here, also a scale. Okay, so now from this 55 image, here from this 55 image I only take for here the median pixel result. So that's why I simply use here the median, and then I simply use here the clip function, because I want to clip with my region of interest Dhaka city. Then simply click to the run. So now it will be just clipping with my shapefile. Okay, and you can also see here which median image I clip this image. I want get only for the one image, because this year of 2020 I can get here the total 55 images. They are get from these 55 images I only calculated the median pixel value, all of the images, and I can get only for the one image. You can see this image also has the 16 bands. Okay, we can get all of this band. You can see it also provides the 16 bands. Okay, and this image will be showing here. Okay, if you want to need the mean or average pixel value between this total 55 images, just you can simply use here the mean. Okay, then click to the run. So now I can get from here the total 55 images mean pixel value result. You can get, it will be appeared in here. If you want to need the max, simply put here the max, then click to the run. Okay, now we can get here the max pixel value result of this 55 total 55 images. Okay, it is the max pixel value result, it will be appeared. Okay, if you want to need the mean pixel value, just simply use here the mean and click to the run. Okay, you can get the mean pixel value. Okay, this result will be appeared here. Okay, so actually what you need is just put here this mean, max, median, pixel, or if you need the any specific images, I already show you that how you can get this image date. So you can see I also try to show you that image date. So simply click to the run. You can get here the all of the image collection information. Here total 55 images will be available here. Suppose you want to work with this image, just you can copy this collection image ID and paste here, and then work with this. Okay, then you only work for this first images. Okay, and which date you want to need, just you can I copy this ID and paste here and work with this. Okay, so I hope you understand this part. Any question?
No.
Okay,
But this is very similar to what we did last class.
Yeah,
but just different data set.
Yeah. And
Okay.
it will be similar, but in this time I also try to show you the another project. This project is for the NDWI calculating using the Sentinel-2 Satellite Imagery. Okay, so for this we need to, you can see here I already uploaded my data set is the Sentinel-2 Satellite Imagery, as well as also imported in my boundary shape file of Dhaka city. So now I want to try to show you the calculated of the dry season NDWI, as well as also calculated the wet season NDWI. Okay, so I simply do this. So first of all I need to take here the 2 season images. Okay, dry season satellite Sentinel-2 images, as well as I also need to add here the wet season satellite images. Then from the satellite images I want to just calculate the NDWI result. Okay, so for this, and we can also import it these satellite images, and I already covered this part in the previous classes, so that you can just follow the same thing. Just you can easily import these satellite images, export these satellite images as a TIFF format, and use these images in ArcMap or QGIS software. Okay, so in this time I will not showing that, because I already showed this part. Okay, So I simply try to show you that. Suppose first of all I remove all of these things, and first of all I just take the two images. My first image is the dry season. Okay, I simply use the dry season comment. I want to take this two season image, dry season and wet season. Then I simply, from the two season images, I just calculated the NDWI, and I also try to show you that part. So first of all I take a variable. I just simply take this variable name is the image dry. You can use any variable name, image dry. I simply use the image dry. Then I simply call my collection, whole collection, Sentinel-2. Then it will be filter bounds with my region of interest is that ROI. I just put here the ROI, and then I just simply put here the filter date. So in this time I simply use here the filter date for the dry season in Bangladesh. So I think this filter date will be that. For the Bangladesh perspective, I simply put here this filter date for the dry season is that it will be start from suppose 2020 1st January, and from the January, then I simply put here the January, February, March, April. Okay, 2020 April, and then I simply put here the 30. Okay, so this is the date for my specific dry season in Bangladesh. I just put this date, and then all of the same thing. Okay, but in this time here I also add the another thing. So we can show about the filter metadata function. It will be calculated our specific properties. Okay, instead of this function we can also use the another function. It's called the sort function. So you can see simply I use here the sort. Okay, this is the another function for filtering the image property. Sort is that you can see sort elements of the arrays along with one axis. Okay, in this time I sort this my image collection using image properties. I simply copy this image properties from here. I simply use here the cloud pixel percentage. Okay, I simply use the cloud pixel percentage, and then I just use here this in paste here, and then I simply use a function use called the false. Okay, it means that this it will be sorting this image pixel percentage, and it will be get for the low image pixel, cloud pixel. Okay, it will be take only for the low. So in this case I simply use here the false. So it will be take the false, or actually it means that it will be taking for the less cloud pixel percentage between this time frame. Okay, between this time frame, and then I simply use a function. It called the mosaic. So I simply use here the mosaic. So mosaic is a function. It will be composite. It will be composite all of the images in a one collection. So it will be composite all of this image collection in a collection. If you want to check what's the mosaic, I simply search here the mosaic. You can see mosaic composites all the images in a collection using the marks. So suppose in this time here I can get here the 2 or 4 or 5 images. So it will be make the composite all the images in a collection using the marks. Okay, so I simply use the mosaic function, and after this I just clip it with my region of interest is that ROI. Okay, and then you can see here I just take these images for my dry season, and then I want to take here the wet season images. I just simply copy this dry season, this code, just paste here, and also put here this is the wet season, and then I simply paste here, and just I simply change this variable name. This is my wet season. I just change it wet season, and I also use here the wet season date. So mainly in Bangladesh perspective we can use here the wet season. It will be start from the January, February, March, April, May, June. It will be start from the June. I simply put here the June, 1st June. Then I simply put here the 2020 June, October. Okay, just put here the October. Okay, this is the date for the wet season. So you can see here I load here the two season images. First of all dry season and wet season I just put here. So now I want to show this result in my map interactive view. After this we calculated the NDWI using this two satellite imagery. So for this I simply use here a variable map dot add layer function. Okay, and then I simply use here the image dry. paste here. After this, I already add here the image visualization parameters. Simply copy it and paste here. After this, I keep the layer name. Layer name is that I simply put here the dry season image. I simply put here this layer name, dry season image, and I also just copy this line of this code and paste here, and just change this variable name image weight, and just put here the image weight, and all of the same. Just simply click to the run. So now I can get this result for the image dry season, as well as also get from here this result for the image wet season. Okay, so here you can see this image will be appear, right? So you can see it will be appear, right? Two layer. First layer is that the image dry season and wet season, it will be appear, right? And then we also use these images for the any remote sensing work, for Landcover classification map, for anything you can do using these images. If you want, you can also calculate the NDVI, NDWI, or any remote sensing analysis we can easily do using this satellite imagery. So here you can see we can just put here the two season satellite imagery, wet season and dry season. It will be appeared, and now you can see here when you move to the wet season, you can see some of the cloud and haze will be available here. You can see cloud, and in the wet season mainly we can see there the different types of cloud will be available in the sky. So that's why when you use this wet season image, here you can see some of the cloud will be available here. Okay, but when you use the Google Earth Engine platform, we can easily remove all of the cloud and haze from our satellite images. Okay, and we also covered this part in our next day classes. So we also try to show you that how you can easily remove all of the cloud and haze and get the clear satellite images for our work purpose. So in this time here you can see just two season images, dry season and wet season. Wet season there is the no cloud, but dry season there is the no cloud, and wet season you can see some of the cloud will be available here. Okay, so we also remove all of these clouds in our next day classes, so that we can easily understand how we can easily remove all of the clouds and haze and get the clear satellite imagery. Okay, so I also need
bro, I just got a email. I have another meeting after maybe 20-25 minutes, so we'll just do 1 hour today, huh?
Okay, no problem.
Okay,
so okay, no problem. This is the wet season. So okay, so you can see here I just simply use here this two satellite imagery. So now I want to calculate it here the NDWI. Okay, so when you work with the NDWI for here, we need to use here the two band. So we use here this two band. I also try to show you that from here. So we use here the green band, and as well as also you need to use here the near infrared band. So here you can see I need the two band B3, it's called the green, and I also need to add here the B8, it's called the near infrared band. Okay, so just I want to use here the two band B3 and B8, then we can easily calculate the NDWI. Okay, so I simply use here the two band, and we already know that we can easily calculate the different types of band combination, and we also cover all of these things in our yesterday classes. So how you can easily use the different types of band calculation. So in this time I just use a function, this called the normalized difference function, so that you can easily understand